This introduction to Python series is part of the EPSCoR Track 2 DDMD workshops. This presentation is dealing with Python strings. Recall that a Python string is a sequence of characters. So in this example, we assign the variable name, the string Carol. We can leverage the type function to print out the data type of the variable name, and you can see that that data type is of class string, str. In this example, our string is comprised of the characters 1, 2, 3. So we assign that string to the variable value. We print out the type of that variable, and we see that its data type is a string. And as we've done many times before, we can convert that string to an integer using the int function. Then we print out the data type of the int value of the string 1, 2, 3, and we see that it's class int. Computers do not deal with characters. They deal with numbers, binary, zeros and ones. Even though you may see characters on your screen, internally it is stored and manipulated as a combination of zeros and ones. This conversion of character to a number is called encoding. The reverse process is decoding. ASCII and Unicode are some of the popular encoding used. This ASCII chart shows the numerical values that are assigned to each character. For example, the uppercase character A is assigned the decimal value 65. Note that the character lowercase a is assigned the decimal value 95. Therefore, in your Python program, if you try to compare uppercase characters and lowercase characters, so if you ask if uppercase a is equal to lowercase a, the result is going to be false because an uppercase a is not equal to a lowercase a. Unicode is an expanded version of the ASCII characters. Unicode was introduced to include every character in all languages and bring uniformity to encoding. Python provides two functions that allows us to encode and decode characters. The ORD function returns the number representing the Unicode code for a specific character, and the char function returns the character represents the specific Unicode. So for example, in our chart, we say that the decimal value for an uppercase A is 65. The decimal value for an uppercase C is a 67. So in our sample program, we assign the variable letter, the character A, and we assign the variable number, the integer value 67. Then we print out the letter and the ordinal value of the letter, and the computer prints A and 65. We print out number and the char of number. Char of number will take the 67 and convert it to a character, so it prints 67 and C. Let's examine how a string is stored in memory. So we have a variable test string, and we assign it the string computer programming. And we look at how that's represented in memory. We can see that each character within the string is assigned a unique position in memory. So the first character, which is an uppercase C, is assigned the position 0. The length of this string is 20. Notice that the last character in the string, which is a lowercase g, is at position 19, which is the length of the string minus 1. A character's position within a string is referred to as its index. Characters within strings can be accessed using indexes and specifying a range. The index starts at 0. A range of characters can be accessed in a string using the slicing operator : Trying to access a character out of range will generate an error. Specific characters within a string can be accessed using positive or negative indices. For example, test string 5 is equal to the lowercase character t. Test string -11 is equal to the uppercase character p. If we attempt to access characters that are not in the range 0 through 19 or -1 to -20, an error message is generated. For example, if we try to access text string 21, we see that an index error is generated by the interpreter. Here's a Python segment of code that will assign text string computer programming, and then it'll print out the character that is stored at position 5 and the character that's stored in position -11. If you want to extract a chunk of more than one character with known positions and size, it's fairly easy and intuitive. The square bracket syntax is extended a little so that we can specify not only the starting position of the piece we want, but also the ending position. Here's an example of code where we can retrieve a substring from a given string. So for example, we have the string computer programming. We assign it to the variable test string. Now we want to access a substring of test string, and we specifically want all the characters starting at position 9 and up to but not including position 20. So if we look at our string, we see that position 9, the value stored there is an uppercase P. And we see that all of the characters up to but not including 20 includes the entire string programming. So the string programming is assigned to small string. We've mentioned before that Python strings are immutable, meaning that strings are not allowed to be modified. So you're not allowed to change any of the individual characters within a string. So if we try to execute the segment of code test string is assigned the value computer programming, then we try to assign test string 9 to the character P, Python interpreter generates a type error, and this type error specifically states that string objects does not support item assignment. In other words, you cannot change individual characters within a string. There are times when we want to concatenate 2 or more strings. Joining 2 or more strings into a single string is called concatenation. The plus operator does this in Python. Simply writing 2 string literals together also can concatenate them. The asterisk operator can be used to repeat the string for a given number of times. This segment of code presents an example of concatenation. So we have the variable first name, we assign it the value string Carol. The variable last name, we assign it the string Lushbow. Now if we want to concatenate first name and last name, we have a variable full name and we assign it first name, use the plus operator to concatenate first name with a space, Then we use the plus operator again to concatenate last name. So basically we're concatenating first name plus a blank plus last name. And this value is assigned to the variable full name. So when we print out the full name is, we have Carol Leschbau. There's times when we might want to replicate a string multiple times. To do this, we use the string replication operator. When the string application operator, which is an asterisk, is used with a string and a number, it performs the string replication operation. So an example is we have Carol times 3, and the result is a string with Carol replicated 3 times. The length function, len, is a built-in function in Python that returns the length of a string. So the parameter is the string, and an integer is returned that represents the length of that string. Here's an example of a code segment that leverages the length function. So again, we have our test variable that we assign the value computer programming. Then we want to find the length of this string. We use the built-in function len and use our test string as a parameter. Calling this test string will return the length of the string. Then we print out the length of the string, and we see that the length of computer programming is 20. The in operator can be used to determine if a substring is contained within a string. For example, is SD in the address 921 Crestview Drive, Vermillion, South Dakota string? So we can look at that code segment and we assign the variable address to the value 921 Crestview Drive, Vermillion, South Dakota. Then we ask the question, SD in address. That returns true or false. If it's true, then we can print the message, yes, 921 Crestview Drive, Vermillion, South Dakota is in South Dakota. Here, another example of the in operator determines whether or not the character O is in both the first string and the second string. So we have first string is assigned to computer, second string is assigned the string programming. Then we ask the question, if the character O is in first string and the character O is in second string, and if that's true, then we print the message both computer and programming contain the character O. It turns out in Python that there are several characters that are illegal in a string. And for those characters, we use an escape character. An escape character is a backslash followed by the character that you want to insert within your string. An example of an illegal character is a double quote inside a string that is surrounded by double quotes. Here we present 4 examples of when you might want to use an escape character. So the first example, we have a string, he said, what's there? The string is surrounded by single quotes. We want to insert a single quote within that string. So in order for Python to understand what we're trying to do and that we want the single string to actually be part of our string and not be a signal for indicating that we're at the end of our string, we use a backslash single quote. Then our output is, he said, what's there? Our second example is when we want to insert double quotes within a string that is surrounded by double quotes. So each double quote that we want actually to be part of our string, we use a backslash. So in this example, we have, he said, what's there? And this double quotes are part of our string. The third example, we want to insert tabs within our string. A tab is a \T. So in this example, we have name, tab, date, tab, time, and our string includes those tabs. And our last example is when we might want to insert a line feed or a new line within our string. So in this example, we have name, \N, which represents a new line, date, \N, time. And you can see as our output, name, date, and time are all outputted on a separate line. Here's a table representing some of the characters that require the use of a backslash. Python includes a large set of methods that can be used on strings. All string methods return new values. Because strings are immutable, they do not change the original string. The next several slides presents a table showing some of these methods. For example, we have a count method that will count the occurrence of a substring within a string. We have a find method that'll search for a substring within a string. We have some methods that can give us some information about a string. For example, isLower returns true if all the characters in the string parameter are lowercase. IsNumeric returns true if all the characters within the string parameter are numeric. We see that there's a lower method that will convert a string into lowercase. The lstrip returns a left strip version of the string parameter. So lstrip is used to delete all the leading characters mentioned in an argument, and the default is it will delete all the leading spaces. There's also a strip method and an rstrip method. The replace method returns a string where a specified substring is replaced with another specified substring. The rstrip is a method that's used to delete all the trailing characters mentioned in the argument. The starts with method returns true if the string parameter starts with a specified substring. The upper method returns a string where the string parameter is converted to all uppercase. The general format for calling a string method is we have our return value variable is assigned our string variable dot method name open parentheses parameters and close parentheses. So let's look at the example method count, where it returns the number of times a specified substring occurs in a string. So we assign the variable sentence the value hi there, and then we write the code where we want to count the number of times the substring e appears in our string. So we have the variable e count and we assign it sentence dot count e. And this returns the number of times that e appears in the sentence, and e will be equal to 2. Let's consider another example of the count method. Let's write a program segment that counts the number of words in a sentence. And just for simplicity, let's assume that words are separated by spaces. So we have a variable called sentence and we assign it the value, how many words in this sentence. Then we count the number of spaces in this sentence and we assign it to the variable eCount. And lastly, we print out the message, the number of words in, how many words in this sentence is the number of spaces plus 1 or 6. The replace method in Python returns a copy of a string where all occurrences of a substring are replaced with another string. So let's look at our example where we're going to assign the variable address the value Sioux Falls, SD. Now we're going to write a line of code that's going to replace SD with South Dakota. So we have our string address dot replace, and then we specify what substring do we want to replace, and that's SD. What do we want to replace it with? South Dakota. So it calls replace and it's going to replace SD with South Dakota, return that string and assign it to new address. We print out our new address and we see that the new address is Sioux Falls, South Dakota. The find method finds the first occurrence of a specified substring. The find method returns -1 if that substring is not found. The find method is almost the same as the index method. The only difference is that the index method raises an exception if the value is not found. The general syntax of the find method is string.find with parameters value, start, and end. The value or substring is a required parameter, and that's the substring to search for. Start is optional. The start specified what position to start the search. So where in the string am I going to start looking? And the default is 0 if you don't specify a start value. End is also optional. Where do we end the search? And the default is the end of the string. To get a feel for how the find method works, let's write a Python program to find the first appearance of the substring not and poor from a given string. If not follows the poor string, replace the whole not string, whatever's in between, and the poor string, substring, with good. So for example, if we have the string my grade is not that poor, we would replace not that poor with the string good. Notice that not starts in position 13 and poor starts in position 22. So in our example, we want to replace the substring that starts at position 13 and goes through position 25. We want to replace that string with the string good. So when we write our program, we'll use the find method and we'll look for the substring not. The find method will return 13. Then we'll use the find method and we'll look for the string poor. And the find method will return the value 22. Well, 13 is less than 22, so we know that poor follows not. Therefore, we want to replace the string with good. So we're going to start at the position of not, and we're going to include every position up to poor plus 4. And that's what we're going to replace with good. Here is one example of a solution to the Python program to find the first appearance of the substring not and poor from a given string, and if not follows poor, it replaces the whole string with the substring good. Sentence is assigned the value my grade is not that poor. Next, we use the find method to search for the substring not within the sentence and return the position of not if it appeared. And in our example, position not is assigned the value 13. Next, we use the find method again and we look for poor within the sentence. And again, in our example, the find method returns the value 22 and assigns it to the variable position poor. Our if statement checks three cases. First of all, did not actually appear in the string. If position not is equal to -1, it means that the substring not did not appear in the sentence. So it checks to make sure that the position not is greater than a -1. Then it checks to make sure that poor appeared in the sentence. So it looks to make sure that position poor is greater than a -1. And then lastly, it looks to make sure the position of poor is greater than the position of not. In other words, poor appeared after not in the string. So our Boolean expression for our if statement is if position not is greater than a -1 and position poor is greater than -1 and position poor is greater than position not, now we can replace our not that poor string with good. To do that, we use the replace method. And we replace the string starting at position not and including everything from the starting position of poor plus 4 because there's 4 characters in poor. So we're going to replace that entire string with the string good. And then we're going to print that sentence. Let's write a program that determines if a string is a palindrome. A palindrome is any string which remains unaltered when reversed. So for example, the string 1, 2, 3, 2, 1 is a palindrome. The string RACECAR is also a palindrome because they read the same frontwards and backwards. Let's think about a strategy for determining if a string is a palindrome. One of the ways we could approach this is to process each character in the original string and append it onto the beginning of the new string, thus having the new string be a reverse of the original string. At the end of this process, our new string would contain the same characters as the original string, but in reverse order. Then we would be able to compare the new string with the original string, and if they're equal, that would mean that the original string was a palindrome. So we begin by assigning the new string the first character in the original string, and therefore the new string becomes equal to the character R. Next, we'll add the second character in the original string, which is A, to the beginning of the new string. Therefore, the value of the new string is equal to AR. Now we add C to the beginning of the new string, making the new string equal to CAR. E is appended to the beginning of the new string. The new string now becomes ECAR. The C that's in position 4 of our original string is appended to the beginning of the new string. The new string becomes CER. The character A that's in position 5 of the original string is appended to the beginning of the new string. The value of the new string is equal to ACECAR. And finally, the last character in our original string, which is R, is appended to the beginning of the new string, making the new string equal to the value RACECAR. After we've appended all of the characters in our original string to the new string, we are ready to check to see if the new string equals the original string. Our program to determine whether a string is a palindrome, we want to look at the input, process, and output. Our input will be a string entered by the user. Our process will be reversing the characters in the user string to create a new string. And then our output will be informing the user whether or not their string was a palindrome by comparing the original string with the new string. So our algorithm for our palindrome program would be to first ask the user for a string. Then we'll initialize our reverse string to the empty string. So to begin with, our reverse string will have no characters in it. Then for each character in the user string, we'll add that character to the beginning of the reverse string. After we've completed that process, if the reverse string is equal to the original string, that means that the original string is a palindrome. Otherwise, the original string is not a palindrome. Here is an example program that determines if a string entered by the user is a palindrome based on our algorithm. Our first statement prompts the user to enter a string. The string entered by the user is assigned to the memory location original string. Next, we're going to initialize our reverse string to the empty string. Take note that to initialize a string to an empty string, we just use either double or single quotes with nothing in between. Python provides a for loop construct that allows us to process the characters within a string individually. So this for loop allows us to process each character in original string, process it in the for loop body. So in this for loop, for each character in the original string, we're adding it to the beginning of the reverse string. On the completion of this for loop, reverse string now contains all the characters that were in the original string, but they're in reverse order. In the if statement, we can now check to see if the original string is equal to a reverse string. That's either true or false. If it's true, we print the original string as a palindrome, else we print the original string is not a palindrome. So in our example, when I execute it, I type in race car, and our program determined that race car is a palindrome.